So in this section, we're looking at how to find the area of a regular polygon. And what we mean by regular is like a regular pentagon or a regular octagon where all the side lengths are congruent and all the angles are congruent. All right, now there is a formula on how to find this, but let's see if we can maybe kind of derive that formula or think about how we could find the area of a regular polygon. So for instance, right here, we've got a regular pentagon. So think about how you could maybe divide this thing up into some other shapes you might know and find the area that way. So you've probably already thought about it by now. If you take this and make it into triangles, because we know how to find the area of a triangle. So if I make a triangle like this, for instance, I could find the area of that triangle and then multiply it by, well, how many can I make here? It's a pentagon with 5 sides. I could make 5 triangles. Okay, so that's what I had right here. If you just find the area of one triangle, multiply it by 5, boom, you'll get your area of this regular pentagon. So that's not the exact formula. It's not the exact way we're going to do it, but that will help us come up with a formula to find the area of a regular polygon. Whoops. I guess I need to clean my projector. Okay. So on your note sheet, first thing it says is it talks about deriving an area formula. So I do want you to write this down. It's very logical. So the first step here that I've got already written down, this stands for area of a polygon, a regular polygon, of course. So far we've said the area of a polygon can be made up of n number of sides times the area of one triangle in the polygon. Okay, now we've got a few steps, as you can see right here, to actually derive the formula. So let's see what else we can do with this. So n number of sides times area of a triangle. Well, area of a triangle is base times height divided by 2, or 1/2 base times height. So I'm just going to replace that with the formula for that triangle. Okay, so this 1/2 base times height, when it talks about the base and the height, it's not talking about of the polygon, it's talking about a triangle you could draw in the polygon, right? So like, let me see here. If I drew this triangle, it's talking about the base and the height of that triangle, okay? So rather than use base and height for the triangle, let's see if we can replace those with letters that represent something in the whole polygon. For instance, this base right here, well, think about what part of the polygon that is. The base of the triangle is simply a side of the whole polygon. So instead of B for base, I'm going to replace that with S for side. Okay, and then this is going to be new. Our height in our triangle, as you can see, I've got it labeled here on your note sheet. If we're talking in terms of the whole polygon, the height of this triangle is something called the apothem of the whole polygon. Okay, and I have the little definition of apothem written here. I would jot that out to the side on your notes. An apothem is simply, in a polygon, it's simply the distance from the center to a side. Okay, so it's distance, so it's always going to be perpendicular, and it always bisects the side. All right, so notice I circumscribed a circle around this polygon to show you different parts of the polygon. So you'll sometimes hear about the radius of the polygon. So the radius is different than the apothem. Apothem goes from center to the side. The radius goes from the center to a vertex. All right, and the reason why we call that the radius is because if you circumscribe a circle around any polygon, that would literally be the radius of that circle. Right, it'd go from the center and it would hit the circle. Okay, so different parts of our polygon there. All right, so back to our formula. Instead of B for base, H for height, we make that a side length and the apothem. Okay, so just kind of doing some substitution here. Now we can condense this formula a little bit more. If you think about it, we've got N, which represents the number of sides, and then we have this S, which represents the length of one side. So think about that. N number of sides times one side would give you the perimeter. So instead of N times S, we can simplify that a little bit to simply just perimeter. So that leaves us with this formula. 1/2 times the apothem times the perimeter. And that is the area formula for any regular polygon. Now, I'm going to add one more step because I like to look at this as apothem times perimeter divided by 2. That's the formula I'm going to use. So it's a really simple formula. So it seems like it would be a really easy process, but it can get pretty complicated if you're looking for your apothem or your perimeter. So you might see some trigonometry, some special right triangles, stuff like that. Skip over that. Okay, so let's actually do an example together. Hopefully I don't get cut off, but with my luck, I probably will. All right, so it says, example 1, find the area of the given regular hexagon. So on this first example, I wrote out the few steps that I use just to kind of help you out on the first one. I won't do that with the other ones. So these are the steps that I follow every time, and it works every time. So first thing I always do is I draw one of the triangles. Okay, so I look at my picture they give me, draw my little center point, and I just draw one of those triangles. Okay, and I then find what's called the central angle. Okay, because I need to do some math on this triangle down here, but I need to know some stuff about it. So I can easily find this angle. Now it's called a central angle because if you think about, you could put a circle around any regular polygon. And if I do that, this would be the central angle of the circle. Now to find a central angle, we know that all of them add to 360, so we simply do 360 divided by however many sides we have. We are dealing with a hexagon, so we're going to do 360 divided by 6. So we get, here, let's write that out. So our central angle is 360 divided by 6. So our central angle is 60 degrees. Okay, so I'm going to label that here. So first steps I always do, I draw my triangle, I find my central angle. Okay, this leads us to step 2, which is draw the apothem. All right, so I'm going to go from the center, drop that straight down. Okay, so basically it cuts this triangle into 2 congruent triangles. All right, so it's easier for me anyway, and I would recommend you do this. Now you have this right triangle that we're going to work with. I always draw a right triangle out to the side, make it a little bit bigger, and then I just do all my math on that triangle. Okay, so this triangle just represents this one that I just made. Okay, so coming over here, let's label it. So our central angle, that 60 degrees, gets cut in half, so this is 30 degrees. Of course, this is going to always be 90 once you draw that apothem. So we end up with a 30, 60, 90 triangle here. Okay, so thinking ahead to our formula for area of this polygon is apothem times perimeter divided by 2. So ultimately, I need to find my apothem, I need to find my perimeter. In this case, the perimeter is really easy to find because they give us a side length of 15, right? So we just need to do 15 times 6, right? What would that give us? 90? Yeah. So our perimeter is really easy, but we need to find this apothem. So if we look over here, I'm going to label my apothem as A. A for apothem. Is there anything else I know about this triangle? Well, I do know the side length is 15, right? So this whole thing's 15. If I cut that in half, this is 7.5. All right, so using my properties of special right triangles, this is actually pretty easy. If I have my short leg and I want to go to my long leg, I simply take that and multiply by root 3. So my apothem is just 7.5 root 3. That's it. Now I could also get my hypotenuse right here, which is the radius of this polygon, but that's not necessary because I don't even need that side, okay? So now I've got my apothem. We decided our perimeter is 90, so let's plug all that into our area formula. Oh, I'm totally not showing you the steps here. That's step 3. Go ahead, so y'all can write that down. Use trig or special right triangles to find the length of the apothem, which we just did. All right, plugging into our area formula, we have our apothem times our perimeter, all divided by 2. Now from here, we're not going to do an exact answer just yet. We're going to go ahead and plug this all in and get a rounded answer in our calculator. So just be careful when you put this in your calculator. I would do it in steps. I'd probably do 7.5 root 3, press enter, then hit times 90, press enter, and then do all that divided by 2, press enter. Okay, so just do that carefully. I'm not a big fan of combining all this in one step unless you're really good with like your parentheses and stuff like that.